Welcome back, guys. So in the last video, we had created a calculator in which we learned the basic data types of Rust. Those data types were mostly integers, or in the last we also used a float number. We also defined the control flow of uh, of Rust using if and else. In this video, we'll mainly learn the advanced data types. Those data types will include enum and structs. We'll so see those in a minute, as well as we'll also learn about the ownership concept. We'll create some extra functions, and we'll also use the switch statements in the control flow. Okay, so just a point before restarting the coding, that the calculator here is complete. You can see the calculator working. Whatever we do it, whatever we are going to do right now is just to explain the concepts which I have mentioned earlier, and they have nothing to do with the code logic. The code is working fine right now. The calculator is working, but in order to learn the concepts which I mentioned, we'll make some changes in the current code, and we'll see how those concepts are used inside the Rust code. Okay, so first of all, we have been using this main function mainly, and all the code uh, is put inside this main function. But what we can do, we can also create additional functions as in any coding language to perform some basic tasks, and then we can call those functions from the main function. So right now what we'll do, we will create another function. Let's create a function called, we'll call this calculation, and you can see here the function is never used because we have not called it inside the main function. Okay, so right now let's just add um, fnum of type uh, I32, let's say x32. Okay, and snum again f32, and let's say the operation type, and that will be IA. Just ignore this right now because I'm going to change it in a bit. Okay, so before we call the calculation function, let's start with the enum and structs. So what is a enum? Enum is a special data type which we can define inside our code, and we can refer to those data types wherever we want. Uh, let's suppose, for example, we define enum operations, and so what are the operations that we can perform inside our calculator? We can call those addition, subtraction, multiplication, and division. So right now we're using just these four operations. So we'll call those in the operation inside the enum function, and we'll add some more operations as well in a bit to define the data types. But right now we're just going with these four operations. And other thing that we can define is a struct. Struct can be regarded as an object if you are familiar with some object-oriented programming languages uh, like Java. So what we define in a struct is a combination of different types of uh, data types that can be combined to form a single data type. Let's create a struct here. and let's call it, we'll call it calculation data. So what this struct will contain, it is that it will contain first number, which will be of type I32. It will contain a second number that will also be I32, and it will contain operation type, which will be of type operations. So this struct will contain three types. The first two will be the operation, the numbers which we want, and the third type will be of enum operations, and it will define what kind of operation we want to perform there. Okay, so right now what I'll do, inside this calculation function, I'll delete this and I will simply replace it with the calculation data type. So right now we have modified our the function definition of calculation. Let's go here, and instead of calculating the result in these, let's call the calculation function here. So how we can call calculation function is that we because we need to pass a struct there, so let's pass a struct inside this. How we can pass the struct is that if you point towards the error, it will tell you that we have not provided the structs data right now. So for convenience, I will rename this as fnum and snum. We'll see why I rename that. So what we'll do, I will say first num as first number. Oh, sorry, fnum. Then we have snum as second number, and operation type. So operation type, as you can see here, operation type is of type enums operations. So we will pass operation double colon addition. So as you can see, the the error has gone. Similarly, we can just copy this and we can call it here. Instead of addition, we can call subtraction, multiplication, and division. One thing to note here is that the code is not optimized. This is not the optimal approach to call a function. Obviously, there is a lot much better way to do this, but I'm just going to explain how these things works. So I'm not assuming that this is the best approach. There are obviously at least two, three more approaches to do this in a better fashion. You can try to do this yourself as well. That will be highly encouraging. So okay, so in order to proceed with the calculation, we need to perform a check on the calculation data's operation type field, so that we can perform the operation according to what is required. Now let's try if statement like we did previously. Let's say we say that data dot operation type is equal to operations dot addition. So as sorry, as you can see here, it's showing an error. That's because the equal sign or the logical operators are only applicable to the integer or the number type. We cannot use it with the non-number types. So we will replace this one with a statement which is called match. In other languages, we use it as a switch. If you might be familiar with it, but in Rust it is called match. So we will call match and data dot operation type. So let's see what's the error here. You can see here the non-exhaustive patterns addition and one more not covered. So what happens here is that we need to cover all four operations in this match code base. So as you can see, the Rust compiler is very helpful. That if we miss somewhere inside coding, it gives us a very comprehensive insight into what's the error there. So let's proceed with operations dot addition, and we'll call it here. We'll right now we'll just copy it, and subtraction, multiplication, and division. As soon as we complete the division part, you see that the error is gone. So inside here we can then simply what you can say, we can simply add the data types, data dot first number plus data dot second number, and right now let's okay you know what, let's just go towards this error. So as you point towards here, it's what it's giving is that it expected these brackets and found I32. So what this error mean is the that in Rust we don't use return keyword. If you want to return some value from a key from a function, we do not need a return keyword. We just simply write it plainly at the end of the code. So as you can see in the function definition, we have not given it any information about the return. So therefore, this function is not expecting to return some value. But right here, the result of this addition is being returned. So therefore, it's it's throwing the error. So to make it more clear, let's save it in a result, and I simply write result here. This means that this result is now being returned from this function. So it will give us the same error, expected these brackets and found I32. It means that the result, the data type of result is I32 and it's being returned, but it's not mentioned in the function definition. So therefore we need to, um, what you can see, we need to we need to mention it in the inside the function definition. So how we mention the return type, we will simply write I32. So as soon as we write this one, the error goes away, but the error occurs here that now it's expecting these three to return I32, but it's getting none. So we'll just return now. We won't use the result keyword. We'll simply do what we did in the last video. Oops. Okay, so right now the error has gone. Okay, so let's save it and run the cargo run command. Okay, well, let's say 1, first number will be 13, second number will be 21, and your result is 0. Where is this 0 coming from? Is here, because we have initialized the result here, but we have not changed the value of result anywhere after that. Therefore, it is uh, printing the only the initial value of the result. So what we need to do here is that we need to equal this to result. Now the error here is that result is f32, as we saw in the last video, that we converted it to f32 due to the division and the decimal parts, but the function of calculation returns the I32. So we'll just simply change it to I32 right now, because we know why we changed the F32. uh, why we changed the type of result to F32. So you know the concept behind changing it. So you can change it back to F32 as well whenever you want. But right now we'll just to proceed forward, we'll just do it like this. Okay, so we'll do this with all three functions and we'll save it. We'll run it again. I'll do the subtraction right now, and first number will be 40, second number will be 21, the result is 19 here. So that's how you define the enums, define structs, initialize structs, and call a function from the main function and return the value from this. So this is uh, how it all gels together. So these are basically the data types. We have learned two data types here, enums and the structs. We have learned how the match keyword works. We have learned how to create a new function. We how to mention its return type and all that. But we still have to cover few more data types as well, and we will cover those in the next video. Right now what I will recommend is to go through these two previous video and practice those, because these are the core of all the concepts in the Rust, and all the other concepts will stem from it. So I would highly recommend to revise these two videos before proceeding forward, and I'll see you in the next video.